Hello everyone, thank you very much for watching this video. I'm Mr. Matt and this is Dr. Todd. Dr. Todd, do you want a cookie? Start class, very good. Welcome to SAT ACT Prep. This is quick drill set A to solving with substitution and solving conceptually. So in the live sessions we got into two different ways of solving. Oftentimes these questions are in multi-statement form, where they give you three different statements and you have to test which of the three, if any, are true, and most of the time at least one of the statements is true. And then pick the correct answer selection that contains all of the correct statements, the correct combination of statements. And we went about that two different ways. One with substitution, by identifying the appropriate domain of each variable. That just means the appropriate or the acceptable values that we're able to use for each of the missing components. And then picked easy to work with numbers, substituted in, and then checked whether the answer returned the characteristic that it says, whether the result is even or odd or negative or positive, so on and so forth. The second type of pathway to a solution that we talked about is solving conceptually, and oftentimes that's a lot quicker and it's less error prone. When you choose to sub in with some of these statements, it can get really hairy. There's a lot of tricky, tedious multiplication, and sometimes it's not going to be a calculator allowed section, so the multiplication won't be very easy. But if you can think about the numbers conceptually, oftentimes it helps a lot. There are predictive outcomes when we're multiplying even, odd combinations, as well as when we're subtracting or adding. So we're going to go through those. Let me share my screen with you and then look at a few examples of some advanced SAT, ACT questions. So the document for this lesson is available on Certified Learning Center's website. The link is going to be in the description below, and just make sure that you're looking at the correct document. If you look at the upper right hand corner, it should have that exact reference number 1001-7. If you got that, then you know that you're at the right place. But I want to go through, before we look at the first question, just remember there are predictive outcomes when we're multiplying, dividing, adding, or subtracting even and odd combinations. So let's look at addition and subtraction. So if we have an even-odd combination here, there are predictive outcomes that we can always rely upon logically. So if we have an even plus an even, that's always going to result in an even value. If we have an even plus an odd, that's always going to result in an odd value. If we have an odd plus an even, that will always be odd. And if we have an odd plus an odd, that's going to be even. With multiplication and division, and with division, you just need to make sure that you're talking about whole numbers, of course. But we can also use these combinations to determine some predictive outcomes. So an even times an even will always be even. An even times an odd will always be even. An odd times an even will always be even. And an odd times an odd will always be odd. So we can always rely upon substitution by picking easy to work with numbers once we understand which numbers we're allowed to use, plug them in, evaluate, and pick the answer selection that has the correct combination of those statements. but that can be very tricky sometimes and can be very error prone. When we can think about these questions conceptually, oftentimes it simplifies them greatly. So we're going to use these concepts in the following questions. I'd recommend that you pause the video and attempt the problem and then unpause the video to watch the solution. So question number 1 asks, if m and n are positive prime integers greater than 2 and q is an even integer, which of the following statements is or are true? Statement 1 says m times n plus 2 times m times n is an odd integer. Statement 2 says 3 times m squared plus 2 times n squared is an even integer. Statement 3 says 5 times q minus 3 times n cubed is an odd integer. Take a few moments and solve that problem. So if we were going to solve this problem with substitution, we just identify the domain here, which they described m and n as being prime integers greater than 2. Recognize that that's just a really tricky way of saying odd, because the only even prime number is 2. So if you're talking about a prime number greater than 2, it has to be an odd number. And then they tell you that q is an even integer. Integer also just means whole number. So if we were picking easy to work with numbers, maybe m would be 3, n may be 5, and q could be 2. So you could sub in and evaluate here, but let's start to think about these statements conceptually. M and n have to be odd, q has to be even. So statement 1 is going to be an odd times an odd plus 2, which is even, times m times n, which is an odd times an odd. An odd times an odd will be odd. An even times an odd will be even, and even times another odd will be even. Now we have an odd plus an even, that will be odd. So statement 1 is true. For statement 2, we have 3 times m squared. Well, 3 is odd. M is odd, and so m squared is just an odd times an odd, 2 odds times each other. Plus 2, which is even, times n squared, which is going to be an odd times an odd. An odd times an odd is odd. That odd times another odd would still be odd. And then an even times an odd would be even. That even times another odd would still be even. An odd plus an even is going to be odd. So statement 2 is not true. Statement 3, 5, which is odd, times q, which is even, minus 3, which is odd, times n cubed, which is just 3 odds times itself. So an odd times an even is going to turn into an even, or is going to be even, I should say. Now, an odd times an odd times an odd. If they're all odd, they're going to stay odd. If they're all even, multiplying by each other, they're going to stay even. So this is going to result in just an odd. An even minus an odd is odd. So statement 3 is true. So your answer here is going to be, answer selection B, 1 and 3 only. Question number 2 says, if m and n are positive prime integers greater than 2 and q is an even integer, which of the following statements is or are true? M times n times q plus 2 times n times q is an even integer. Statement 2 says q squared times m squared plus 2 times q times n squared is an even integer. Statement 3 says 5 times m times q minus 4 times m times n cubed is an even integer. Take a few moments and solve that problem. So they didn't change anything about the domain here, so if we wanted to solve with substitution, we could use the same values as m being equal to 3, n being equal to 5, and q being equal to 2, because they satisfy the characteristics of m and n being positive, odd, prime numbers, and q being an even number. But thinking about these conceptually, m times n times q So that's going to be an odd times an odd times an even, plus 2, which is an even, times n, which is an odd, times q, which is an even. An odd times an odd is odd, an odd times an even is even. An even times an odd is even, and that even times another even is still even. An even plus an even number will result in an even sum. So 1 is true. 2, q squared, so that's going to be an even times an even, times m squared, that's going to be an odd times an odd, plus 2, which is an even, times q, which is an even, times n squared, which is an odd times an odd. An even times an even is an even. An odd times an odd is an odd. An even times an even is an even. And an odd times an odd is an odd. An even times an odd will remain even. So we're going to have an even plus an even, which will always remain even. So statement 2 is true. 3, we have 5 times m times q. So 5 is odd, times m, which is odd, times q, which is even, minus 4, which is even, times m, which is odd, times n cubed, which is going to be 3 odds. Odd times odd will be an odd. That odd result times an even will be even. So this on the left-hand side is going to be even. An even times an odd is going to be even. That even times another odd will still be even. That even times another odd will still be even, so on and so forth. So this whole thing on the right is still going to remain even. An even minus an even is even. So 1, 2, and 3 are true, so your answer here is going to be D, statements 1, 2, and 3. Question number 3 asks, if m and n are positive prime integers greater than 2 and q is an even integer, which of the following statements is or are true? Statement 1 says the quantity q minus m quantity cubed plus the quantity 35 times m times n quantity squared is an even integer. Statement 2 says the quantity 37m plus 29q quantity squared plus 17 times n squared is an even integer. Statement 3 says the quantity 85q quantity squared minus 93n quantity cubed is an even integer. Take a few moments and solve that problem, please. So once again, they didn't change the domain. So if we wanted to rely on substitution, we could use 3 for m, 5 for n, and 2 for q because they satisfy those characteristics described in the question as being prime positives and odds greater for m and n, and evens for an even number for q. But thinking about these conceptually, we're going to have q minus m. So we're going to have an even minus an odd, quantity cubed, plus 35. Now if you're using substitution, I would sub out 35 and not use 35 and use a smaller odd number, because the only thing that matters there is 35 is an odd number. So if you were calculating this out and multiplying all these values, I would not use 85, 93, 37, 29, 7. You can sub out for odd values because that's the characteristic that's being tested within each statement. So if you match that up, you can use easier to work with numbers, but you have to make sure that you understand the concept that's being tested and apply it correctly. But going back here, we'd have 35, which is odd, times m, which is odd, times n, which is also odd quantity squared. So an even minus an odd is going to be odd, so we're going to have an odd cubed, plus an odd times an odd times an odd, that's all going to remain odd, that's going to be squared. no matter how many times you multiply an odd times itself, it's still going to be odd. So this is going to be an odd plus an odd. An odd plus an odd, however, will turn even. So statement 1 is true. Statement 2, if we think about this, 37 times m, 37 is an odd number, m is odd, plus 29, which is odd, times q, which is even, quantity squared, plus 17, which is odd, times n squared, which is going to be an odd times an odd. So an odd times an odd will be odd. An odd times an even is going to be even. An odd times an odd times an odd, that will still remain odd. An odd plus an even is going to be odd. So this is going to be an odd squared plus an odd. An odd squared is still going to be odd, but an odd plus an odd will turn even. So statement number 2 is true. Statement 3, 85, which is odd, times q, which is even, quantity squared, minus 93, which is odd, times n, which is odd, quantity cubed. An odd times an even is going to be even, so it's going to be an even squared, minus an odd times an odd is odd, so that's going to be an odd cubed. An even times an even, or in other words, an even squared, is going to be even. An odd times an odd times an odd is still going to be odd. An even minus an odd will be odd. So statement 3 is not true. So our answer is going to be statements 1 and 2 only, which is answer selection A. Question number 4, if m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1 says the quantity m times n times q, quantity squared, times the quantity 2 times m times q, quantity cubed, is a positive integer. Statement 2 says the quantity negative 3 times m times q, quantity cubed, divided by 5 times n times m, quantity squared, is a positive integer. And statement 3 says the quantity negative 2 times m times n, quantity cubed, times the quantity negative 3 times m times n times q, quantity cubed, is a positive integer. Take a few moments, please, and solve that problem. So here we've changed the domain of m, n, and q. It's no longer representative of positive prime odd values for m and n, or an even value for q. Now we're talking about integers less than 0, or in other words, negative values for m and n. And we're talking about an integer greater than 0, or in other words, a positive value. Oops, excuse me if I could spell here. For q. So if we wanted to pick easy to work with numbers, maybe m could be negative 1, n could be negative 2, and q could be positive 1. We don't want to pick values that are going to make our life hard for ourselves. So number 1, we have m times n times q, quantity squared. So that's going to be a negative times a negative times a positive. So a negative times a negative times a positive, quantity squared, times 2, which is positive, times m, which is negative, times q, which is positive, quantity cubed. Now you need to recognize that raising a negative number to an odd power is going to retain the negativity. If you raise anything to an even power, if you raise a negative number to an even power, any even power, it's going to remove the negativity. But odd powers will retain the negativity. So that's a little bit, that can be tricky sometimes. You have to watch that. So on the inside of the left parentheses set, we have a negative times a positive. So we have two negatives. Those are going to cancel out. So a negative times a negative is a positive times a positive is a positive. So overall, this is going to be a positive value squared. On the right, we have a positive times a negative times a positive. That's going to be a negative because there's only one negative. There's an odd number of negative values, so that's going to retain the negativity. And that's going to be a negative number cubed. A positive number squared is positive. However, a negative number cubed is going to remain negative. A positive times a negative is going to be negative. So statement 1 is false. Statement 2, we have negative 3 times m times q quantity cubed. So we have a negative times a positive quantity cubed divided by a positive times n, which is a negative, times m, which is a negative, quantity squared. So a negative times a negative is positive. That positive times a positive will still be positive. So this is going to be a positive cubed divided by a positive times a negative will be negative, but that negative times another negative will turn positive. So that's going to be a positive squared. A positive cubed is positive. A positive squared is positive, so this is going to be a positive answer. So statement number 2 is true. Number 3, we're going to have a negative. We have negative 2, so that's a negative times m, which is negative, times n, which is negative, quantity cubed, times a negative 3, times m, which is negative, times n, which is negative, times q, which is positive, quantity cubed. A negative times a negative is positive. That positive value, however, times that last negative on the left is going to retain that negativity. So we're going to have a negative value cubed on the left. On the right, we have a negative times a negative times a negative. That's still negative, so that negative times a positive will be negative overall. So we're going to have a negative value cubed. Remember, if we raise anything to an odd power, that's going to, if it's negative at first, it's going to still be negative at the end of the exponentiation. So a negative value cubed is still going to be negative. However, a negative times a negative is going to turn positive. So statement 3 is true. So our answer here is going to be statements 2 and 3 only, which is answer selection C. Question number 5 says, if m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1 says the quantity m times n, quantity cubed, times the quantity negative 3 times m times q, quantity squared, is a positive integer. Statement 2 says the quantity 3 times m times n, quantity squared, divided by the quantity 5 times n times q times m, quantity cubed, is a positive integer. And statement 3 says the quantity negative 2 times m times n, quantity squared, times the quantity negative 3 times m times n times q, quantity cubed, is a positive integer. So please take a few moments and solve that problem. So we haven't changed the domain of m, n, and q from statement number, question number 4. So we could still use maybe negative 1 as m, negative 2 as n, and positive 1 as q if you wanted to use substitution here. But thinking conceptually, here we're going to have a negative times a negative cubed times negative 3, which is negative, times a negative times a positive squared. A negative times a negative is going to be a positive, so this is going to be a positive cubed, times a negative is a positive. That positive times a positive will be positive overall, so we're going to have a positive squared. A positive cubed is positive, a positive squared is positive, and a positive times a positive will stay positive. So statement 1 is true. Statement 2, we have 3, which is positive, times m, which is negative, times n, which is negative, quantity squared, divided by 5, which is positive, times n, which is negative, times q, which is positive, times m, which is negative, quantity cubed. So a positive times a negative is going to be negative. That negative, however, times another negative will be positive. So that's going to be a positive squared, divided by a positive times a negative is negative. That negative times a positive is still negative. That negative result times that last positive, though, is going to turn the whole thing positive again. So that's going to be a positive cubed. A positive squared is positive. A positive cubed is positive. A positive divided by a positive will remain positive. So statement 2 is true. And statement number 3, we have negative 2, which is obviously negative, times m, which is negative, times n, which is negative, quantity squared, times negative 3, which is negative, times m, which is negative, times n, which is negative, times q, which is positive, quantity cubed. A negative times a negative times a negative is going to be negative, so it's going to be a negative squared on the left. A negative times a negative times a negative, that will be negative. That negative times that last positive is still going to be negative, so that's going to be a negative cubed. A negative squared will turn positive, however, a negative cubed will remain negative. A positive times a negative will result in a negative outcome. And so statement 3 is false, so your answer here is going to be 1 and 2 only, which is answer selection A. Last question. If m and n are integers less than 0 and q is an integer greater than 0, which of the following statements is or are true? Statement 1 says the quantity negative n times q, quantity squared, times the quantity negative 2 times m times n times q, quantity cubed, is a negative integer. Statement 2 says the quantity negative 3 times m times n, quantity cubed, divided by the quantity negative 5 times q times m, quantity squared, is a negative integer. And statement 3 says the quantity 2 times m times n times q, quantity cubed, times negative 3 times n times q, quantity cubed, is a negative integer. So take a few moments and solve that problem, please. So we're working with the same domain as we've been with 4 and 5. So again, we could use maybe negative 1 for m, negative 2 for n, and positive 1 for q. Thinking conceptually here, statement 1, we have negative n. So that's going to be a negative times a negative value. So a negative negative is a positive. So negative n is going to be a positive, times q is a positive, quantity squared, times negative 2, which is negative, times m, which is negative, times n, which is negative, times q, which is positive, quantity cubed. A positive times a positive is a positive, so we're going to have a positive squared. A negative times a negative is a positive. That positive times a negative is a negative. That negative times a positive is still negative, so it's going to be a negative cubed. A positive squared is positive, but a negative cubed, because it's an odd power, is going to remain negative. A positive times a negative is going to be negative. So statement 1 is true. Statement 2, we have negative 3, which is negative, times m, which is negative, times n, which is negative, quantity cubed, divided by negative 5, which is negative, times q, which is positive, times m, which is negative, quantity squared. A negative times a negative times a negative is negative. So we're going to have a negative cubed, divided by a negative times a negative, that's going to be a positive, and that's still squared. A negative cubed is going to remain negative. A positive squared is positive. A negative divided by a positive is going to be negative. So statement 2 is true. And lastly, we have statement number 3, 2, which is positive, times m, which is negative, times n, which is negative, times q, which is positive, quantity cubed, times negative 3, which is negative, times n, which is negative, times q, which is positive, quantity cubed. Positive times a positive times a negative is negative. That negative times a negative will be positive. That positive times another positive will be positive. So the left-hand side is going to be a positive cubed. Times, on the right, we have a negative times a negative. That will be positive. That positive times a positive will remain positive. So that's going to be a positive cubed. A positive cubed is positive. A positive cubed is positive. A positive times a positive will be a positive answer. So statement 3 is false. So our answer here is going to be A, statements 1 and 2 only. If you have any questions on anything that we've done today, then please let me know in the comments below. If you find these videos helpful, please like and subscribe and share with your friends. I'm here for you on my social media if you have any questions. And please let me know. I hope you have a wonderful night, and I will talk to you all soon. Dr. Tot, you want to say goodbye? Come on. You guys say goodbye to everybody. I know, you knew right when. Come on, let's say goodbye. Can you say bye? Come on. Bye. Say bye. Can you say bye? Say bye. Can you say bye? Okay, that's good. Thank you guys very much for watching. I'll talk to you all soon.